Greetings, everyone. Today we're going to do a quick review of Unit 9. Unit 9 involves graphing and solving quadratics and also real-world problems involving quadratics. All right, we're going to start with two examples. Now, these two examples actually cover the entire unit. This first example involves everything to do with the graphing and solving the quadratic. So first of all, when you are provided with a polynomial, you need to make sure that that polynomial is in standard form, meaning everything has been moved to one side and set equal to 0, and that the degrees are in descending order. So the first thing I notice is that that 3 is on the right side, and I want to kick it to the left side. So I'm going to subtract 3, which means my standard form is going to be 4x squared minus 4x minus 3 equals 0. This helps me identify my a as 4, my b is negative 4, and my c is negative 3. To find my axis of symmetry, this is a formula you are going to have memorized. The formula is negative b over 2a. Again, you need to have this memorized. We've created lots of different ways in our notes and note cards and previous videos to help us remember this. So to start off, my b value is negative 4, but the formula also has a negative. So that means a double negative. And then I have 2 times a, which is 4. So double negative becomes positive. 2 times 4 is 8. Always reduce your fractions, so we end up with 1/2. Now this is what x equals. So x equals 1/2. That is my axis of symmetry. So we need that axis of symmetry of x equals 1/2. So we can plug that in as our middle value, our line of symmetry on our graph. So from 1/2, we want the values around it. My suggestion is to graph the line x equals 1/2 and then see what x values are around it. To the left of 1/2, I have 0 and -1. To the right of 1/2, I have 1 and 2. Make sure that's an even spread amongst those values. Now we want to take each value and plug it in for the x's. All right, so I'm going to look for that work. I want to see that work. So to start off, if you want to show your simplified work, you could certainly do that. What I might recommend at this point is to jot this down, pause the video, plug this in, practice using your calculator. This is a lot of parentheses and signs that we have to be concerned about. So I actually recommend doing it piece by piece. So what I mean by that is after you fill that in, take care of -1 squared is 1. 1 times 4 is 4. -4 times -1 ends up being add 4 and then the -3. Now if I do 4 plus 4 minus 3, 8 minus 3 is 5. So see how that makes it easier? You don't even need the parentheses for any help. All right, 0 squared times 4 is 0. 4 times 0 is 0. And 0 minus 3 is -3. Let's jump to the whole numbers, just because they're easier to solve. So 1 squared is 1. 1 times 4 is 4. -4 times 1 is -4, minus 3. 4 minus 4 is 0. 0 minus 3, -3. I'm seeing that symmetry that I need. 2 squared is 4. 4 times 4 is 16. 4 times 2 is 8. Minus 3. 16 minus 8 is 8. 8 minus 3 is 5. All right, so here's where we maybe need to do a little bit of work to make sure that we're correct. So I have 1/2 squared, which is 1/4, or 0.25. 0.25 times 4 is actually 1. 4 times 1/2 is 2, and then minus 3. So 1 minus 2 is going to give me -1. -1 minus 3 is going to give me -4. So as I take a look, this makes sense. First of all, it's symmetrical, excuse me. We go from a high number to lower to lower, and then lower to higher to higher. So we see that, I should say, drop my arrows the other way, sort of this outwards pattern from that -4. So once you have that table created, you see the symmetry, then we want a graph. So let's take a look at the graph. Let's start by graphing our axis of symmetry. Our axis of symmetry was at 1/2. So I want to see that dashed line where my line of symmetry is at 1/2. Now if I plot my points, I had -1, 5, 1, 2, 3, 4, 5. I had a point at 0, -3, 1, 2, 3. I had a half at -4. That's in the middle there. I've got right 1, down 3, 1, -3, and 2, 5. So right 2, up 5. So pretty skinny parabola, but make sure you still have a curve right there. Make sure you go up through those points. Okay. So now I see that parabola. Now mine's a little bit sketchy, I apologize, with the tablet here, but you want it to look like a clean U, you want arrows on the ends, and you want the axis of symmetry. Let's identify a few things here. First of all, if I want to identify the vertex is going to be, again, where the axis of symmetry occurs. So that 1/2, -4. I want to see the whole point. Make sure it's in point form, meaning x, y. It is going to be a minimum, and it is concave up. Take a look at your notes or note cards to work on what's a min and max and what is concavity. The last piece is going to be to solve the quadratic. So what that means is my quadratic is equal to 0. And I want to solve to find out what does x equal when y is 0. So my first option is always to try factoring. So we've got previous review videos on factoring if you need to look back at those for more details. But I'm going to start with my x. A times c is 4 times -3, which is -12. My middle value, my b value, is -4. This is just to help us set up our thinking. We're looking for two numbers that multiply to get -12, but add or subtract to get -4. So think of the factors of 12, 1 and 12, 2 and 6, 3 and 4. Well, if I look, 2 and 6 could get me to 4. That would have to be a -6 though in order to work. So from here, your next step is you're either going to use grouping or the box. So it depends on which method you are more familiar with. So I'm not going to review that, but make sure that no matter which method you use, you end up with 2 factors. So please pause the video, take a second to try that factoring. All right, so once you reach those factors, we should have ended up with, let's take a look, a 2 and an x and a +1. And we should have had a 2 and, let's see, an x and a -3. So you could FOIL that or use the box to make sure that that's correct in the end. Okay, but those are my 2 factors. Now we set each factor equal to 0. So I have a 2x + 1 = 0, and I have a 2x - 3 = 0. So this one did factor. So I'm going to solve, subtract 1, and then divide by 2. So I end up with x equals -1/2. Here I'm going to add 3. 2x = 3, divide by 2, and end up with x equals 3/2. You can leave them as decimals or fractions, that doesn't matter to me. Now what if it wouldn't have factored? I'm also going to show the other option or the other item you are going to encounter. These are not going to be all factorable. So if it's not factorable, then you have to use that quadratic formula. You have to have that memorized for the test. So think of that little tune, practice writing it over and over again. That's one way to remember. Think of it like when you learned spelling words. When you were learning spelling words, you wrote them repeatedly so it would help your memory. Same thing with formulas. So I'm going to start by plugging in my values. So negative b, or negative 4, excuse me, is your b value. That means I've got negative 4 squared minus 4 times a times c all over 2 times a. So simplify the basic stuff. A double negative is a positive. 2 times 4 is 8. Let's take care of what's underneath. So a little bit of work is required here. Negative 4 squared is 16. And negative 4 times a 4 times a negative 3, I'm going to be adding on, is going to be positive. 4 times 4 is 16. And then we're going to have 16 times 3. So we end up with 48. So if I add those together, 16 plus the 48, we have 64. So 64 is what's going to go underneath my radical. Now, reducing radicals, you are going to have to review that. In this case, we ended up with a good perfect square. So square root of 84 is actually equal to 8. Okay, so now if I read this two ways, I actually have two things I'm solving for. I have 4 plus 8 divided by 8, and I have 4 minus 8 divided by 8. So 4 plus 8 is going to be 12. 12 divided by 8 is 3 halves. Then I have 4 minus 8, which is negative 4. Negative 4 divided by 8 is negative half. So you'll notice that we're on the right track because we got the same two answers no matter which way we solved. Now notice those are located on your x-axis. My x-axis. So if you take those values, they should be on your parabola on the x-axis. All right, let's take a look at the second type of main example that we're going to encounter from this unit, and that is applying quadratics in the real world. So my suggestion, as always, in any word problem, whether it be in math class, a standardized test, science class, I always recommend to first just read it through. You don't have to understand the math, just read it to get an idea of the scenario. And then I always recommend second to underline. Identify the key information that we're talking about. So I have an object launched at a 19.6 meters per second, which I interpret that as a speed, from a 58.8 meter tall platform. The equation for the object's height s at time t seconds after launch is this equation, where s is in meters. Find the object's maximum height and the time at which it reaches maximum altitude. So I'm going to draw a little sketch to understand it. I'm launching an object from a height of 58.8 meters, and it's launching into the air and then it's going to land on the ground. So definitely I need to underline my equation. I need the equation no matter what. I also know that S is in meters is important because that's my units. S is height, that's important to know, and T is time and seconds. So units are important for labeling and for understanding if it makes sense or not. So if I take a look, I'm trying to find the maximum height and the time. So if I was to label my axes, usually x is time. Well, if I look, t is in the place of x in the equation as well. And s is my height. So this is height on my y-axis, which is represented by the letter s. So if I'm looking for the maximum would be my vertex. So my goal is to find my vertex in order to answer this question. So in order to find my vertex, I have to go back to what I know from my previous example. I need to find my axis of symmetry because that's going to be the x value of my vertex. So x equals negative b over 2a is what I'm going to need. So if I go ahead and plug in, my b value is negative 19.6, or excuse me, the b is 19.6. the negatives from the equation, and then 2 times a, which is negative 4.9. So I need to plug that into my calculator. Some of you need to be very careful with parentheses. So maybe you should take 2 times negative 4.9 first. Maybe take care of that first so we don't make any parenthesis errors. So now if I divide those two numbers, I know that a negative divided by a negative is a positive, so that's taken care of. And we end up with exactly 2. Now that's my x equals 2. Notice x is time. So this is currently 2 seconds, which answers the second part of my equation. At what time does it reach the maximum altitude? At a time of 2 seconds. So there's my first part. Now, if I know my x value, to find any y value, I need to plug it into the equation. So wherever there's a t, I'm going to put a 2 because I want to know, hey, what's the height at time 2? So plug it in for every t value. Be very careful with parentheses. Maybe do it piece by piece so you don't make any, let's say, parentheses errors. So I've got a negative 19.6. If you take care of that, 19.6 times 2 gets me to 39.2. Then I'm adding on 58.8. So I'm just kind of doing it in little chunks so that I don't make a silly calculator error. All right, so if I combine all of that, I end up with 58.4. That's what my y value is. So the y value of my vertex is the height. So my height, my max height, is 78.4, and I have to label if it's height. It's meters because of what I've underlined in the question. So to answer both questions, the max height is 58.4 at time of 2 seconds. And that makes sense. Let's talk about why it makes sense. Because I'm launching from 58.8 meters, that's right here, and I'm going up to 78 meters. So that could make sense. I don't know what I'm launching or how it's being launched, but it's not negative, it's not smaller than, and it's not outrageous. So it makes sense. One last quick review of reducing radicals. In our example in these slides, it ended up being a nice clean x value. So we have to review perfect squares. Remember to make that list off to the side of your test. That makes it much easier to reduce your radicals. I want you to make sure that you can create this list quickly and efficiently. All right, so I want to take a look and reduce that 72. So what's a good and a bad that I can reduce that 72? Now remember, good and bad is just some terms I use to explain perfect square and non-perfect square. We want the largest value that goes into 72. So please pause, use your calculator, and check to see what that is. And in this case, it's 36 and 2. Yes, there are other perfect squares, but I want the largest perfect square. So square root of 36 is a perfect square because it equals 6. 2 is bad because it stays bad. Now notice I've got a 2, a 6, a 3. Some of that stuff can reduce down. So to reduce, I'm going to separate, meaning I separate the numerator, and each numerator gets that 3 denominator. So negative 2 over 3 does not reduce, so that's going to stay. But 6 over 3 reduces down to 2. 2 over 1, but I don't need the 1 in the denominator. So I have 2 square root of 2. So that would be my final reduced radical answer. All right, so this has been just a very quick review of the main concepts of this unit. So some ways to study and review. Take a look at previous videos that have been posted. We've taken notes on all of this. So review your notes, make yourself a little mini test, and then grade it yourself. We have all of our assignments. Okay, all of those are posted in Google Classroom, so you could rework some problems in the section where you're struggling. In class, we've made some note cards. Okay, or if you were not there, or if this is at another time and we didn't make note cards, make your own. Use those to review. And then of course we have this video. You could watch it with a friend. You could re-listen to it. Teach your parents something. Okay, so teaching others really solidifies that understanding. And these are just a few ways to study. There are so many ways to study. Okay, but here's the thing, I can guarantee if you spend any time studying, you will do better than if you had not studied. So it is worth it. We're at the end of the year here, so this also matters very much to end on a good positive note with our grades. So let me know if you need any help. Keep in touch. Study, 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 and we'll see you soon.